are discussing matrices. Let us understand the meaning of matrix. We have students A and B. These are their marks in class 10, 11 and 12. We can represent this information in the form of a matrix. We can write it like this. This is 92, 70, 87. This is 80, 75. This is 90. So we have arranged the information in two rows. This is the first row, row 1. This is second row, and three columns. This is column 1. This is column 2, and this is column 3. So we have two rows and three columns. 2 into 3. This is called order of matrix. So order is number of rows into number of columns. Horizontal lines are rows, columns are vertical lines. These are horizontal lines. The same information we could have represented in a different way. That's 92, 80, 70, 75, 87 and 90. So here we have three rows. Row 1, this is 2, and this is row 3. Similarly, we have two columns. That is, we have represented the same information now in a 3 by 2 order matrix. 3 rows and 2 columns. Horizontal lines, I repeat, are rows. The vertical lines are columns. So in this representation, what does row 1 represent? Row 1 is 92 and 80. 92 and 80. What are 92 and 80? These are marks in 10. Marks in class 10 or marks in 10th. The second row, this is marks in class 11 and in 12. This is for student A, this is for student B. And in the first representation, the first row is marks of student A in class 10, 11 and 12. And second row, marks of student B in class 10, 11 and 12. So this is the idea of a matrix. We can have a matrix like A. Let's write a journal matrix of order m into n. M is number of rows and n is number of columns. So the first element we write A11, A12, A13 and so on, A1n. A11 means element at the intersection of first row and first column. This is element at the intersection of first row and second column, and so on. Next, A21, 22, 23 and so on, A2n. These are elements of the second row. And we have m rows. So AM1, AM2, AM3 and so on, AMN. These are elements of the mth row. In between, let us say we have ith row. So we can write elements of ith row like A, this is I1, AI2, AI3, AIN. These are elements of the ith row. Similarly, we can have jth column somewhere here and elements A1J, this is A2J, this will be AIJ and so on. This is AMJ. This is called journal element. We can say this is A is Aij in order m into n. This is how we denote a matrix. Matrices are of different types. For example, this one, there are 2 rows and there are 3 columns. This one is a rectangular matrix where number of rows and number of columns is different. So we have a rectangular matrix if m is not equal to n. If m and n are different, we have a rectangular matrix. Rectangular matrices are of 2 types, horizontal matrix and we have vertical matrix. This one is the horizontal matrix and this is vertical matrix. So we have horizontal matrix which is of order, let's say 2 by 3, and this is 3 by 2. So in horizontal matrix, number of rows m is less than number of columns, and here number of rows is more than number of columns. So if a matrix is spread horizontally, it's a horizontal matrix, and if it is spread vertically, it's a vertical matrix. Similarly, we can have a row matrix. If elements of a matrix are like this, let's say A, B, C and D. Single row of elements is a row matrix. This is order 1 by 4. 1 row and 4 columns. It looks like a row, therefore it's a row matrix. Similarly, column matrix. If elements are like this, 1 omega, omega square, this is example of a column matrix. Then we have square matrix. A matrix is square if number of rows and number of columns is equal. If m is equal to n. It's a square matrix. Let us write a square matrix A of order 3. We can say 3 by 3, or since it's a square matrix, it's square matrix of order 3. These are the elements, let's say A, B, C, D, E, F, G, H and I. These are diagonal elements. These are diagonal elements. So the diagonal elements are A, E and I. This is called diagonal, also called principal diagonal, or its main diagonal. But there is only one diagonal, and that is having these elements. So what are these elements? This is element at the intersection of first row and first column. So it's at position 1. Then this one is an element at the intersection of second row and second column. This is 2, 2. Similarly, this is 3, 3. So these are diagonal elements. A square matrix is called a diagonal matrix. Next type. If elements are like this, we have A, E and I, and all the non-diagonal elements are zeros. This is a diagonal matrix. If non-diagonal elements are zeros, one of these can be zeros or two of these can be zeros. And we have a scalar matrix next type. If all the diagonal elements are equal, we have A 0 0, this is 0, A and 0, 0, 0 and A. So if all these are equal, it's a scalar matrix. And this becomes a unit matrix or identity matrix, unit or identity matrix if these elements are, diagonal elements are 1, 1 and 1. Non-diagonal elements obviously zeros. This is called unit or identity matrix of order 3, I3. Next, we have upper triangular matrix. This is A, B, C, let's say 0, D, E, This is 0, 0 and this is F. So principal diagonal and above that we have triangle, it's upper triangular matrix. The necessary condition is that elements below diagonal are zeros. We may have zeros here, but these are necessarily zeros. Similarly, this one is a lower triangular matrix. We have, let's say, A, B, C, then D, E, F, 0 here, 0 here, and 0 here. This is lower triangular matrix, triangle below the diagonal and zeros above. These are necessarily zero elements. And if all the elements of a matrix are zeros, it may be of any order. It's called null matrix. We write with O. This is null matrix. This may be a square matrix or a rectangular matrix, or even a row matrix or a column matrix. Let us discuss next concept. This is construction of a matrix. This is matrices and this is matrix. Matrices is plural, whereas this is singular. Singular is matrix and matrices are, okay, that is plural word. Let's say we have to construct matrix A equal to Aij. This is, let's say, order 2 by 3, where Aij, this is equal to I plus j square. So this matrix will have 2 into 3, 6 elements. That's right, this is matrix. We have 2 rows. So first row A11, A12, A13. Second row elements A21, A22 and A23. So this is a 2 by 3 order matrix. So with this element we have I is equal to 1 and j is also 1. This is the rule to write elements. Aij is I plus j square. So what will be this element? This will be I is 1. We substitute I equal to 1 here and j equal to 1 here. 1 plus 1 square. Next, for 1, 2 element, I is 1, j is 2. This is 1 plus 2 square. Next, 1 plus 3 square. And elements of the second row, this is I is 2. So 2 plus, it's 1 square. 2 plus 2 square. 2 plus 3 square. And this is 2, 5. And this is 10. This one is 3. This is 6. And this is 11. This is how we solve questions on construction of a matrix. After construction, we have next concept, that is on equality of matrices. Equality of matrices. Let's say we have matrix say Aij, order m by n, B, general element Bij, order p by q. If I say matrix A is equal to matrix B, this means the following. 1. Aij is equal to Bij for every I common j. That means the corresponding elements are equal. And 2. M is equal to P and N is equal to Q. And N is equal to Q. So if matrices are equal, then their corresponding elements are equal. M is equal to P, N is equal to Q means M by N is same as P by Q. That is, they are of the same order. That's the key word. Two matrices are equal if they are of the same order, and also their corresponding elements are equal. Let's solve a question based on this concept. We are given matrix which is A plus B. This is 2, 5. This is AB. This matrix is given equal to 6, 2, 5 and 8. The question is we have to find out values of A and B. So we have to find out A and B. We can see the two given matrices are of the same order. This is square matrix of order 2. Both are, you can say, square matrices of order 2. This is order 2, this is also order 2. So they are of the same order. We can see they are of the same order. Second is that the corresponding elements are equal. So that means A plus B is equal to 6. 2 is equal to 2, that is true. 5 is equal to 5. And also AB is equal to 8. This means B is equal to 6 minus A. We substitute value of B from this here. This is A into 6 minus A. That's 6A minus A square. Or A square minus 6A plus 8 is equal to 0. That's A2 or 4. If A is 2, then B will be 6 minus 2, that's 4. And if A is 4, then B will be 6 minus 4, that is 2. So we have two answers. A is 2, then B is 4. And if A is 4, then B is 2. These are the two answers. Let us next discuss addition, subtraction and scalar multiplication of a matrix. Say this is A, these are the elements 1, 2, minus 1, this is 3 and this is 4. This is matrix A. Scalar multiple of this means like 3A. 3A is multiply each element of matrix A by 3 to get 6 minus 3, this is 9 and this is 12. We can find out minus of A means each element of A multiplied by minus 1. This is minus 2, 1, minus 3, this is minus 4. This is scalar multiplication. So here 3 is scalar, here minus 1 is the scalar. Scalar multiplication of a matrix. Let's say this is A and this is B. This is 0. We have matrices A and B. We can see these are of the same order. So if matrices are of the same order, we can add matrices. We can find out A plus B. We simply add the corresponding elements. So we add 2 and 5 to get 2 plus 5, 7. Minus 1, minus 7, this is minus 8. 3 minus 4 and 4 plus 0, that is 4. So obviously we get a matrix which is of the same order. This is 2 by 2, this is 2 by 2. And let's say we have matrix C which is 5 minus 7, this is 1, minus 4, 0, 1. Then what is A plus C? We say A and C are not conformable to addition. The reason matrices can be added only if they are of the same order. This is matrix of order 2 by 3, this is of order 2 by 2. So they cannot be added. We say A and C are not conformable to addition. A and B are conformable to addition, and we can find out sum of A and B. Next, let us discuss properties of addition of matrices. First property, A plus B, this is equal to B plus A. And we know this is called commutative property. We have commutative property, that is order doesn't matter. If we add B to A or A to B, the result is the same. Next is A plus B plus C. This is same as A plus B plus C. Again, order doesn't matter, but this is for 3. This is associative property. So matrix addition is cumulative as well as associative. If we add null matrix to a matrix, the result is the same matrix A. So A plus O is equal to O plus A is equal to A. This is called, this property is existence of an additive identity. This is existence of an additive identity. And one more, A plus minus A, this is equal to null matrix. Minus A is negative of matrix A. This property, this is existence of additive inverse. So what is additive identity? Additive identity is null matrix of the same order. Order of matrix A. Null matrix of the same order. And what is existence of additive inverse? Additive inverse is nothing but negative of A. That means for every matrix A, we can find out its negative or additive inverse. Let us next solve question on addition and subtraction. We have to find non-zero value of x here. Question is, find out non-zero value or values of x. This is the question. Let's solve it. So this is matrix of order 2 by 2. Same 2 by 2. This is also 2 by 2. We have plus sign here. That means we have two matrices of the same order on the left hand side. So we can add. This is scalar multiple of matrix. Let us multiply each element of first matrix by x to get 2x square. This is 2x. Similarly, we multiply second matrix, each element of that by 2. This is 16, 10x, 8. This is 8x. Similarly, on the right hand side, this is 48, this is 20, and this is 12x. Left hand side we have two matrices of the same order. These are matrices which are conformable to addition. That means we can add these matrices. Let us add. We add the corresponding elements. 2x plus 10x is 12x. This is 3x plus 8, x square plus 8x. This is equal to 2x square plus 16. This is 48, 20. This is 12x. So now we have matrices which are equal. That means the corresponding elements are equal. So this is equal to this for every value. 12x is equal to 48. This gives us x equal to 4. This is one of the values, but this value must satisfy this equation as well as this equation. Let's solve this equal to this. 3x plus 8 is 20. This means 3x is 20 minus 8, 12, or x is equal to 4. So we are getting x is equal to 4 from this as well. Let's solve this one. X squared plus 8x, this is equal to 12x. Shift 12x to the left hand side. Take x common. Now we have product of two factors equal to 0. This means the first factor is 0, that's x is 0, or the second factor, x minus 4 is 0, or x is equal to 4. X is equal to 4 is the value which satisfies all 4. This will be true for all values. 1, this is 2 and 3. The 3 of equations give us x is equal to 4. So x is equal to 4 is the final answer. One more. We have to find matrices x and y. We have to find matrices x, matrix x, matrix y. If this is true, 2x minus y, this is equal to 6 minus 6 is 0, minus 4, 2 and 1. And also x plus 2y, this is 3, 2 and 5. Then minus 2, 1 and minus 7. We have to find out values of x and y. Matrix x and matrix y. We can solve these equations like simple algebraic equations. Multiply first equation by 2. We get 4x minus 2y. So multiply this by 2 means this is 12 minus 12. This is 0. This is minus 8, 4 and this is 2. Now we have two equations. These are same. This is plus, this is minus. We add. Adding, we get x plus 4x, that is 5x. This is equal to, this is 15, this is minus 10. This one is 5. This plus this is minus 10. We have 1 plus 4 equal to 5. Minus 7 plus 2 is minus 5. We have 5x equal to this, or x is, now for x we divide each element of the matrix by 5 to get 3 here, minus 2, this is 1, minus 2, 1 and minus 1. Next, we can substitute this value of x, let's say in the first equation. So we have 2 into x, 2 into, that's 3, minus 2, 1, minus 2, 1, minus 1, minus y. This is equal to 6, minus 6 and this is 0. This is 6, minus 4, 2, minus 4, 2, minus 2. And bring this to this side. This is 6, minus 6, 0, minus 4, 2 and 1. Shift y to the right hand side. We have 0 here, minus 4 plus 6, 2 minus 0. This is 0, this is 0 and this is minus 3. So this is y. This is how we find out matrices x and y.